Hey guys, it's Josie with Queen My Pawn, and I'll be talking about tables. I plan to skip this question since it wasn't algebra related, but I've been getting requests to do the tables question. It's a two-part question, but since you guys want to see how it's solved, then I guess I'll have to show it then. Okay, so let me share my screen. Now here's the thing about tables. You have to read the question carefully because deducing information about the table is really easy. Like the people that did not vote with ages between 35 and 54 is 177. But of course, the questions are going to be trickier than that. So let's see. A survey about voter participation in the 2012 US presidential election was conducted among a randomly chosen sample of US citizens. So basically, after voting or after election day, they conducted this and they got this data. The table summarizes the results by age group. And so there we have the age groups. According to the table, which age group has the greatest percentage of people who reported voting in the 2012 presidential election? So there's no percentages here at all. So we had to convert the number to a percentage. And basically, you got to convert the number to a fraction. And here's why. You have to look at which age group has the most voters. Normally, if this question was which age group has the greatest number of people who voted, then yeah, this would win. Because here's what you do. You look at the age groups and you look at the voted. Terrible circle. And as you can see, 35 to 54 would win because that's the biggest number there. But it wouldn't be fair, for example, to the 75 and older people if there weren't that many of them to begin with. And that's true. There's only 177. So what if this group really did vote the most, but they just don't have the numbers to show for it? That's where percentages come in. And that's why we had to divide 303 by 630, 471 by 743, and so on. In the end, you have to calculate all those numbers. In the end, you should get the biggest number being 431 over 600, equaling 0.71833 . You could stop right there and just click C as your answer. It'll be correct. That's not what I meant to do. Just meant to go to the mouse, and there you go. But I must show you, in case you need to convert decimals to percentages, how to actually do it. Well, if you have this number, I'm going to show you in red now. This decimal needs to be converted to a percentage. Well, you need to move it 2 steps to the right. And it is the decimal point. After moving the decimal point 2 steps to the right, you'll get 71.83, depending on where you round. You could stop. So I round to the 10th, I get 71.8%. I round to the 3, that's if I round it to the hundredths. 71.833 if I round it to the thousands. That's the tens place, the hundreds place, the thousands place. And in order to convert the percent back to a decimal, then you just move it back 2 to the left, put a 0 there, erase this, and you get 0.718. Now the point, the threes will be missing, but that doesn't matter because you rounded. And the precision isn't necessary. So that's it for number 10. Moving on. It's loading. Okay, now it says this is the same thing, but you can read to make sure. Because questions 10 and 11 refer to the following information. You can save actually 15 seconds up to, unless you're a speed reader, in which case it's probably 3 seconds. You could save time just by knowing that questions 10 and 11 refers to the following information. You don't have to reread this. I could save you time. And that's at least one question where you can go double check. So that's like an extra 20 points on your SAT score. A second sample of 50 people. Okay, so I already know this is going to ask me for a proportion because they are using smaller numbers. And it's referring to the first group because it said a second. So anyways, a second sample of 50 people from the age group 18 to 34 who reported voting in the 2012 presidential election were selected at random and asked which candidate they voted for. Of these people, 29 responded that they voted for candidate A. So 29 out of 50 voted for A. And 21 out of 50 responded that they voted for someone else. So we could just say someone else. Based on this information, which of the following is the most appropriate estimate of the number of people from the 18 to 34 age group in the survey who voted for candidate A in the 2012 presidential election? Yeah, I knew it was a proportion. So here is how you definitely know that it's a proportion. Suppose that you have a pool, a small pool in the summertime, and it's in a city where no one really travels, so, or no one moves out or in. And in the summertime, you have 13 people that are over 5 foot, and you'll have 6 people that are less than 5 foot. That's an ugly looking 5, but this means more than 5 feet, less than 5 feet. Now in the winter time, there's obviously going to be less because it's going to be colder. If it was cut in half, then obviously we'd have something between 6 to 7, and you would just have 3, 6 to 7 over 5 feet, and 3 less than 5 feet. It's basically a proportion. The traffic got cut in half, and then you got that. So it's the same thing here in the original group. That number that voted, because they voted, so you can't count people that did not vote and no response. You just can't count those. That means you can't count the total. That's a typical mistake. It's always about details in these questions. So the total number that voted was 303. And in the sample, it was 50. 29 voted in that small sample. How much was the number here? Well, there's 2 ways of solving it. I can show you the quick way. I'll show you the slow way first. The multiplicative inverse of 1 over 303 is just 303. Here's what I mean. 29 over 50 equals x times 1 over 303. That's what you're really doing. That's the same thing as saying x divided by 303. This is your shorter way to write it. But this long way shows that it's clear that you should multiply by the multiplicative inverse on both sides. And this will give you 1. And anything times 1 is anything, as I've shown in the video, why does 0 equals 0. So in the end, by the way, you're multiplying 303 and 29. It's just unclear there because of the space. In the end, you get 29 over 50 times 303 over 1. You could put it that way too. And after doing that math, you should end up getting 176, and that is, of course, going to be the answer. So the takeaway is this: when you're looking at tables and you're asked questions about tables, you have to be very careful about what they're asking you and look at the right details, because it's very easy to make those tiny mistakes, forgetting that, oh, the total is not just the people who voted, it's also those that didn't vote. And you shouldn't count people that didn't vote, because if they didn't vote, they can't vote for candidate A or candidate someone else. So they can't be counted. So I hope you enjoyed the video. Make sure to subscribe, click the like button, and stay tuned for more content. I'll see you in the next one.